Sweet, thanks. I got so engulfed in the science, I forgot I was supposed to go meet at the door at 2 o'clock. My name is Marshall Baker. I'm an assistant professor here in the Department of Agricultural and Human Sciences. And so my science is, I'm a social scientist in the College of Ag and Life Sciences. And so a lot of times that brings an interesting perspective. What I'm looking to do is to help translate your science, a lot of your science, translate that to communities, to families, and to youth that will be consumers of that science. And so we do understand with cognitive psychology how people perceive science, and that's a big challenge. A lot of the research looking at rural receptivity of science and how we can work to improve that. Specifically, I study the cognitive psychology of how people learn, grow, and behave. And that is grounded in experiential learning theory, which talks about the fact that all of us have sensory experiences, the environment that we live in, and then how do we make sense of those experiences and come to conclusions and beliefs that then will drive our behaviors. And so often in the College of Ag, we see a lot of science that is being produced, but I like to look at I start with youth because they're the best mechanism for me to produce change. How can we prepare a society to accept and understand and be scientifically literate to consume and interact with your science? And so my primary mechanism, the specific problem that I address, is we have high school agri-science students throughout the entire state. And so that gives us a phenomenal mechanism to help impact every single community and tens of thousands of youth that will be directly involved with many of these sciences. So my outcomes are looking to recruit those people to science and to help them ultimately become scientific, literate citizens. So I'd love to collaborate for any of you that have scientific, some of your science, if you need some help moving that towards education or outreach or the human dimension, I'd love to work with you.
Good afternoon, everyone. My name is Jade Berry James. I'm an associate professor in the Department of Public Administration on campus here. I'm in the School of Public and International Affairs. And so one of my research interests, my primary research interest is really around social equity. I like to say that I practice in creating usable knowledge, looking at policies, programs, and practices that really promote fairness and justice in our field and in our society. I'm a program evaluator, and I have an expertise in assessment and accreditation. I've been doing that work for about 32 years in higher education now. And so most of the programs that I've evaluated are federally funded initiatives that look at food equity, alternative education, substance abuse treatment programs, juvenile justice programs, and emergency management programs. I have a current book that was recently published this year. It's called Why Research Methods Matter, Essential Decision-Making Skills. And what it really does is it really showcases the power of program evaluation to really look at the kind of knowledge that we're really trying to use to make good decisions in our field and in every field, quite frankly. So my poster presentation today is really about responsible innovation, and it's looking at inclusion strategies in cultural perspectives around genetically modified foods. And so I'm at poster number 2. It's over by the exit door. I hope you'll stop in and see me and say hello at the very least. That research study was really supported by the Genetic Engineering and Society Center here on campus. I believe they're located in the fifth floor of this particular building. And then I'm looking for research collaborations in really 2 areas. One is in public engagement, strategies in science and technology. I love to do evaluation work, which includes needs assessments, as well as connect research to communities, underserved communities in particular. And then the other thing is really focused on building trust in diverse communities. I love to focus focus on the town and gown approach. I really believe that the kind of things that really make us valuable at NC State is our ability to go out and make the world better. Thank you very much. Appreciate my 2 minutes of your time.
Hi, everybody. Philip Bradford. I'm an associate professor in textile engineering program, and my background is in textile engineering and in material science. And so my research kind of combines these two areas in the field of textile nanomaterials. I am an expert in growth of a material called carbon nanotubes, which probably some of you have heard of before, but essentially extremely small diameter fibers. In this field, traditionally, these fibers are microns in length, so when you buy them, they look like a bag of black powder. But my group is focused on producing these materials at a much larger scale in terms of their length scale in order of millimeters. And when we do that, we can translate these into things that look like yarns and things that look like non-woven textile materials. And so they have a lot more useful functionalities than just taking this black powder and mixing it in something else. And so my group has studied these textile-like materials made of carbon, and they have very unique properties: high surface area, high electrical conductivity, high thermal conductivity. And so we've used them for textile-like applications such as filtration, but we're also interested in advanced areas such as energy storage and catalysis and other things. And so there's a lot of opportunity for collaboration using this kind of very novel material as a source of collaboration between different people that are interested in new materials for their particular applications. So my poster is number 4 right as you walk in through the door, so I'd be glad to talk with you all if you have some ideas about collaboration. Thank you.
George Elvin from the School of Architecture, and like Gavin, I work with hurricanes like Florence, which just last year killed 39 people and did over $17 billion in damage just in North Carolina, one state, one storm. And part of the reason for so much damage is, as Gavin talked about, where we build, also how we build is critical in that, and building resilience and resistance to hurricanes. And so the light wood framing system that we use for single-family homes, for example, is efficient and affordable, but not when it goes up against a hurricane. And so we are looking at resilient framing systems for residential buildings and residential scale buildings for the coasts and throughout the state, ultimately throughout the world, since these kind of events are happening with increasing severity and frequency all over. And adapting that light wood frame system and incorporating new systems, some of them going quite traditional, like pole framing that has been around for a very long time, but then also weaving in new technologies like laminated veneer lumber, which hasn't been around very long at all, basically making our buildings stronger and more hurricane resistant moving ahead. So designing this system, building it, testing it at the Constructed Facilities Lab, hopefully within the next year, and then ultimately implementing that. So we're poster number 5 over here. Look forward to talking to you.
Hey everyone, my name is Nathan Crook, and I'll tell you a little bit about what my lab does. We engineer gut fungi for drug delivery to the gut. I want to emphasize that that fungi are a resident of the human gut, and there are in fact probiotics that are fungal in nature, in particular Saccharomyces boulardii, which is interesting because it is a close relative of baker's yeast, and so is engineerable just like baker's yeast is. What we do in our lab is note that very little is known about the roles that fungi play, and use that as an opportunity to engineer them for controlled phenotypes like drug delivery. The reason why fungi are a useful platform is that they can secrete post-translationally modified proteins, which are a major class of biologic drugs. These are very easy to engineer, and we can potentially use them to modulate the growth of bacteria without impacting their own growth. We can also think that they might have some containment advantages relative to horizontal gene transfer in the gut. But what my lab does is focus on this probiotic yeast, Saccharomyces boulardii. We've developed a colonization strategy so we can colonize this microbe in mice. We can control its gene expression very precisely so we can dose this drug as we would like. And we're looking for collaborators in particular in disease models. So we'd like, if anyone is developing drugs against, in particular, gut disease, we can deliver these drugs in a new way. We can also potentially deliver modulators of this disease to test hypotheses about what these diseases are doing. So if anyone's interested, I'd be happy to talk to you. I'm in poster number 6. Thank you.
Good afternoon. I am Kwesi Brookins. I am Associate Professor of Applied Social Community Psychology as well as Africana Studies. I am presenting on behalf of our partnership that we have between the Vice Provost's Office of University Outreach and Engagement, Wake County Cooperative Extension, and Wake County Social and Economic Vitality. As we all know, NC State is a land-grant university. What we don't often think about, however, is the fact that we are also an anchor institution that has a tremendous amount of economic, social, cultural, and economic impact on our local and regional communities. The Office of University Outreach and Engagement seeks to promote, connect, and support faculty, researchers, and students in ways that the university can more intentionally partner with our local communities to have broader impacts on community-identified needs. The Wake Community University Partnership arose out of 3 strategic goals: build a culture of engagement, enhance our community collaboration and partnerships, and develop our capacity to make a difference. The route to accomplish this is built into our framework of faculty responsibilities and a scholarship of engagement, which provides a pathway for transdisciplinary research and scholarship, as indicated in the graphic on the, is that your right or left? Can't remember, okay. This year, NC State signed a MOU with Wake County called the Wake Community University Partnership. The goals of the Wake Cup are to find ways to leverage the intellectual and research capacity of the university to collaborate and partner with organizations in 2 engagement zones, Northeast Wake and Southeast Raleigh. We believe these focal areas that you see here provide opportunities for collaboration by transdisciplinary scholars across the university. And I am over at, what is this, number 9, I think? Poster number 9, and it's right, you can't escape the room without passing by me. So if you do not stop and have a conversation with me about how we can partner, I will not be happy. Thank you.
That's apparently me. I'm Sharon Lupkin. I'm in the Department of Mathematics. I am an applied mathematician, meaning I'm applying the math to real problems, primarily in biology, but not exclusively. I primarily am looking at problems in developmental biology, but also regenerative medicine would be a reasonable area of application. I tend to look at the tissue level. Cellular level happens sometimes, and the tools that my group applies are partial differential equations for mechanics and transport. We're tracking the components of the system by building not a model. There's a misconception of what modeling does, that the task is building the model of the biological system, but a much better way to approach it is to think of creating a set of models and comparing how different assumptions will lead to different insights. So a typical workflow, which I've got on my poster there, has a biological question. So here's a lung question. Why does closing off the trachea increase the level of branching? Not what are the molecules, but mechanically what is going on, physically what's going on. The initial hypothesis from the people who did that lab work was that the tissue gets stretched and that leads to more branching. So we throw a couple of models with very carefully stated assumptions at that and look at where the stretches would be. It didn't seem to fit what was known about the system, and that insight that the first order model didn't seem to work leads to the next model. The next model in this case was, well, there's some transport involved. What is being transported? Would that have anything to do with the biological question? So you can get further details at my poster, but the idea is collaborating on clarifying ideas which sound good when you think about them or sound good when you articulate them, but when you specify them quantitatively, that can be a lot harder to justify. That's my work.
All right, good afternoon. My name is Thomas Chase. I'm a research scholar at ITRI. Our institute was established in 1978. We are under the Office of Research. We are fully grant funded and with no appropriations. We have about 50 staff and around 60 to 80 students, depending on the year and how busy our summer is, that work with us. My background's in civil engineering, and I'm going to talk with you today about our Connected Autonomous Vehicle program, which I lead at ITRI. I also lead our ITS and Signals program as well. ITRI is itself fairly multidisciplinary, but we're always looking for new collaboration opportunities. We have folks that work in design, planning, marketing, economics, and other areas. And when we look at Connected Autonomous Vehicles, we're really interested in the holistic picture of how these systems operate. And in this case, we see both connected and autonomous as separate and combined technologies, and so we're interested in each of those aspects individually and together. I've got a slide with some pictures and then a slide with some words, so we'll switch over to the word slide. Really what we're looking at is building partnerships with collaborators across NC State as well as North Carolina and even internationally as well. Currently, we're working with mechanical engineering, psychology, civil engineering, working with NCA&T, Duke, and the Highway Safety Research Center at UNC. We have active projects working with NCDOT and USDOT, and we're actively developing proposals under NSF programs, DOE programs, as well as looking ways to, again, build the team basis that we've started further through institutional funding. So why am I here? I'm really interested in hearing about all of your research, as well as seeing if there's any opportunities, again, for collaboration. That may be just us finding out what you're doing in the field and using that as a great pitch when we go to sponsor agencies to show the value of working with NC State. It may be that you could use subject matter experts in the transportation field to come alongside you in your projects. We can definitely assist in that side. And we'd also love to, again, work on full team building as well to build collaborative proposals. So I'm poster number 12, and I'd love to talk with you guys about your interest. Thank you.
Good afternoon. My name is Aranza Sue Laskarine. I work for the Southeast Climate Adaptation Science Center. It is a federal university partnership. NC State won the bid about 8 years ago to host it here, and it is funded through the U.S. Geological Survey. The one here at NC State is one of 8 centers across the United States, all housed at public universities. And our mission is to look at the impacts of climate change on wildlife, fish, and ecosystems, and to prepare the tools and scientific data to co-produce that science with natural and cultural resource managers. So here's a map of the territories in which we work, including Puerto Rico and the U.S. Virgin Islands. I wanted to make a pitch that we run an annual request for proposals of $1 million on average per year to fund NC State faculty and our USGS colleagues. And very importantly, I wanted to talk about our Global Change Fellows Program, which we've been in operation about 8 years. And if you can see there by the numbers, we've funded about 68 fellows across 7 colleges, 12 departments. The idea here is to bring together graduate students to think about the multidisciplinary approaches to climate change and to work across these disciplines, to know how to communicate with each other, and to really train the next generation of scientists that we'll need in a changing climate. So I'd love to talk to you. I'm at poster 13, and I'm especially looking for other disciplines to join us, other faculty. We run the selection process for the students every year. We just now finished selection of those students. We have a wonderful incoming class, and I'd love to talk to you more about doing analysis on how well these programs work. So I look forward to talking to you. Thank you.
Hello, my name is Cesar Delgado. I'm an associate professor in STEM education, and my area of research is how students understand and learn about the magnitude of variables, so temporal and spatial dimensions. And I know that that is probably an issue that you have encountered in your classes. If you're in the realm of things that are very large, very small, or take a long time, or take a very tiny amount of time, perhaps we can collaborate and figure out how to help your students understand better these difficult issues in temporal and spatial scale. My poster is over there at 14, and I hope to talk to many of you.